This video provides an introduction to using socket communication with Delta robots. A socket is a communication endpoint defined by an IP address and a port, used for data transmission over a network. In Delta industrial robot applications, the server is typically set up on the robot controller to monitor a specific port. The client, which can be a PC or a PLC, initiates the connection. Once established, both sides can exchange control commands and status information. The core architecture of the socket-free communication protocol is built on the C language, with functions modularized through Lua. By providing the Lua socket extension library as an interface, it enables communication handshakes at the TCP and UDP transport layers. Next, we will introduce how to implement these TCP and UDP transport layer applications within the Delta robot language. First, open DRA Studio and load the pre-edited robot-side socket communication program. For detailed instruction descriptions, please refer to Chapter 12 of the Robot RL Manual. Set the robot as the slave and verify the relevant settings. This includes the port, the receive command delimiter, the send command terminator, and the default timeout for sending commands. Once the configuration is complete. Next, use third-party communication software to test the actual socket data transmission. Set the communication software as the master. Set the IP address of the robot arm. Now, start the execution of the RL program on the robot side. Establish the connection in the third-party communication software. At this point, the master sends data in the format of 12:3. The robot receives the data and returns the numbers 9 and 1 to the master. Verify that the robot has received the numbers 12 and 3, which are stored in the rets 1 and rets 2 positions, respectively. Check if the data has been received. Once confirmed, the configuration for the robot as a slave is complete. Next, we will introduce how to use the robot as a master. Load the pre-edited robot-side socket communication program. For detailed instruction descriptions, please refer to Chapter 12 of the Robot RL Manual. Verify the relevant settings for the master side. Configure the target slave address, the slave port, the receive command delimiter, and the send command terminator. Also, set the default value for sending commands, the interval between command transmissions, and the timeout duration. Once the configuration is complete, use third-party communication software to test the actual socket data transmission. Set the software as a slave, and configure its IP address and port number to match the settings in the robot's RL program. Then, click Connect. Now, start the execution of the RL program on the robot side. The communication software will receive the data 1, 2, and CMD. Click to send back 1 and 2 from the slave side. And verify if the robot has successfully received the data. Once confirmed, the configuration for the robot as a master is complete. This concludes our tutorial on robot socket communication. Thank you for watching.